Pythagorean theorem. Pythagoras lived in the 500s BC. As a philosopher and mathematician, he had many followers. The formula is most commonly written as a squared plus b squared equals c squared. Long before Pythagoras, the Babylonians understood the connection between the legs and hypotenuse of a right triangle. Pythagoras was the first to give enough substantial proof to claim the formula as his own. Some terms most commonly used are hypotenuse and Pythagorean triple. We can only use the Pythagorean theorem if we are given two side lengths at least, and the triangle must be a right triangle in order to use it. Some applications for the formula is to solve for any side, and I have also used it in my Calculus 1 class to solve differentials. The parts of the triangle. There are two legs and the hypotenuse. How to use the formula. In this example, we're solving for the hypotenuse, c. So you would square both the legs and add them together. And when you have that sum, you take the square root of it to get the side length of the side length of the hypotenuse. To solve for a leg of the triangle, you square the hypotenuse, and then you subtract the leg that is given squared, and you take the square root of that difference, and that is the length of your leg. This is a story problem for a differential, and we are trying to solve for the rate at which these two cars are headed towards each other. And the ones that we are going to be using for the triangle are the lengths given at the bottom of 0.4 miles as the x, and 0.4 as the x, and 0.3 as the y. First, we need an equation that is going to relate the x and y and z that are given to us. So we are going to use x squared plus y squared equals z squared. We are going to take the derivative of both sides, and we end up with 2x dx dt plus 2y dy dt and 2z dz dt. And we just divide 2 out of it, and we are going to be solving for dz dt, so we want to get dz dt by itself. This is where we use the Pythagorean theorem also. With the measurements given at the beginning of 0.4 miles and 0.3 miles, we will square both of those and add them together, and that is 0.25, and the square root of 0.25 is 0.5. So z is going to be equal to 0.5 miles. When we plug in these values into the equation that we have for dz dt, we will end up with 56 miles per hour as the changing rate for how fast they are approaching each other. I obtained my information and pictures from MathBlog, History for Kids, Livis.org, and ualr.edu. I came up with the problems myself, and thank you.